Good morning, good afternoon, or good evening. Whatever time of the day it is, I hope that you're having a good one. Okay, our notes that we're going to be working on today is all about parallel lines and angles and triangles and measurements of degrees and things like that. So let's get through our vocabulary part first, and then we'll start working some of these numbers. Okay, the first thing we're going to talk about are parallel lines, which are when we have two lines that are the same distance from each other forever. They are called parallel. And we can create a lot of different angles by drawing a line called a transversal, Transversal, through two parallel lines. And if you look down here, you can see what I'm talking about. Okay. When we do this, we actually create 8 angles, but these 8 angles only share 2 different angle measurements. Okay. We also create 3 different sections of the, actually it's 6 different sections. If we look, we got 1, 2, 3, 4, 5, 6, but we look at them this way. So we got 1, 2, and 3, and the way we call those are interior, I-N-T-E-R-I-O-R, and exterior. Okay. Later in the notes, we're going to talk about the fact that all triangles have 3 angles inside of them, which we should know very well. And these are actually called interior angles, which you may not have known. And those angles always add up to, maybe you can answer this one before I do, what do the angles of a triangle always add up to? They always add up to 180 degrees. Okay. Blank angles, well, we're going to talk about supplementary, supplementary, supplementary angles are 2 angles that are exactly 180 degrees when put together, because what they do is they create a straight line. Okay? Now, there's lots of different rules in math and stuff like that, and we're going to learn about a couple of these today. And what we do is we call these different rules, and there's a couple of weird little names that we use for these, but we call them theorems, which is the first one, T-H-E-O-R-E-M. And you may remember from last year, or if hopefully you remember, what was called the Pythagorean theorem. That's just kind of like a math rule. Okay, and sometimes they call these things postulates. P-O-S-T-U-L-A-T-E-S. And they're just math rules that prove things that we can work with through math, okay? And we'll learn about a lot of these in the next few weeks, but the ones we're going to learn about today, one of them is called the AA, which stands for angle, similarity, S-I-M-I-L-A-R-I-T-Y, and that is a postulate, P-O-S-T-U-L-A-T-E. And the other one we're going to learn about is the exterior angle theorem. Okay, again, these are just math rules that are always true and just help us to figure out certain things about angles and stuff like that, okay? So it's like a lot of geometry. Okay, so what we're going to do is we're going to come down here to these 2 parallel lines, and we're going to draw a line through them. And when we do that, again, we call this line a transversal. Okay, so this is our transversal. And if you notice, I just created a bunch of angles by doing that. So I'm going to number them. 1, 2, 3, 4, 5, 6, 7, and 8. So I got all these different angles I just created. Also, the other things that I created, these 3 sections, well, I've got an exterior section on the outside and down here on the outside. So these are the exteriors, and then this is called the interior. Okay, so exterior, and then interior or inside, and then the exterior or the outside again, okay? Now, there's a lot of different ways to talk about these angles we just created. The first one we're going to talk about is what are called corresponding angles. Okay, so corresponding angles are like 1 and 5. Okay, they're on the same side. So if I cover up that transversal right there, angles 1 and 5 are corresponding angles. Okay, so we're just going to write down a couple examples. There's a lot of them in here, but 1 and 5 are corresponding. Okay, and if you kind of look at them, they're the same measurement. Look at them real close. Whatever this angle is, well, this angle is going to be exactly the same. And the same thing goes for angle 3 here and angle 7. Okay, so I'm going to write those two examples down as corresponding angles. Now on the other side, 2 and 6 are corresponding, and 4 and 8 are also corresponding. Okay, the next thing we're going to look at are what are called alternate interior angles. Well, the interior angles are right in here, and the alternate ones are going to be the ones that are opposite sides from each other because they have the same measurement. See, look at this. This measurement and this measurement are going to be exactly the same. So angle 3 and angle 6, and then also angle 4 and angle 5. And that's that little symbol I'm making, just the angle. It's not a greater than, that's just the angle symbol. Okay? Alternate exterior angles. Well, now we're talking about the exterior, which is just kind of omitting the middle part, so don't worry about the middle part. And alternate means the opposite. So if you look, you should be able to see that angles 1 and 8 are alternate and on the outside, and also 2 and 7. So angles 1 and 8, and then angles 2 and angle 7 are the alternate exterior angles. And then the last one, same side interior angles. Well, here's our interior, and the ones on the same side are 4 and 6. So that's one pair. And the other pair is 3 and 5. So angle 3 and angle 5. Okay? Alright, so let's look over to the next one that we already did. Okay, and the corresponding angles and alternate angles and all those, I want you to figure those out on your own. Okay? And when you write those in, you can just make up numbers. I just would go 1, 2, 3, 4, 5, 6, 7, 8, just like that, and then you fill in those, okay? Now, one of the most important things that, again, that we did when we drew this transversal line here is that we created all these different angles, but there's only 2 different angle measurements. Okay, this angle right here is the same as this one, and this one is the same as this one, and is this one. Okay, these bigger angles are all the same. Okay, and one of the other important things that we talked about up here was that when you have supplementary angles, they always add up to 180. So that means whatever this angle is right here and this angle, if I put them together, they add up to 180 degrees. So by knowing that, I can take this one, which I'm indicating this one is 2x, and this one is just 1x. So if I say 2x plus 1x, and that should add up to 180 degrees, those 2 angles. So then I add my x's, 2x and 1x is 3x. Then I can divide by 3 to figure out that x is represented by the number 60. So that means this angle right here is 60 degrees. And then 2x would be 2 times 60. Tells me that this one is 120. And as you see, both of those angles add up to 180. So these 2 are 180, these 2 are 180, these 2 are 180, these 2 are 180. If I want to do something like this, this one plus this little one down here also add up to 180, because again, we only have 2 measurements all the way around. So this one's 120, this one's 60, this one's 120, this one's 60, this one's 120, this one's 60, this one's 120, and this one's 60. Okay, so that's how that works. We only got 2 different angle measurements when we do that. Okay, so now let's do one that's a little bit more difficult down here. But again, when I look at this, these 2 angles right here, this little one and this bigger one, if you look at that, they make a straight line. So if I add this information together, it should equal 180. So what I do is, I take the things that are similar. So my x's, I got 2x and 8x. I'm sorry, 2x and 6x, which is 8x. Okay? Then I got a positive 30 and a minus 10. Well, that represents a number that's plus 20. Okay? So again, those 2 angle measurements should add up to 180. So just by doing some math that we should be pretty decent at, I subtract 20 from both sides, cancels out, and I got 8x equals 160. When I divide both sides by 8, I get an answer of 20. Now that just tells me what the x is worth. So now I got to come up here and do a little math. Well, 2 times 20 is 40, plus 30 tells me that this angle right here which is actually right there, is 70 degrees. And I really don't even have to do this, because again, I know that these two angles add up to 180. I could just say, all right, 180 minus 70 gives me this. But if I put this number into the equation, 6 times 20 is 120, minus 10 is 110. So now I know this angle right here is 110, and as I said, they both add up to 180. Okay? All right, let's flip the paper over. And we're going to talk about a couple other things here. First, we're going to talk about the fact that if you know the measurements of two angles of a triangle, you can find the measure of the third angle, because as we said before, all three angle measurements of a triangle always add up to 180. Always, always, always. Okay, and this is called the triangle sum, S-U-M, theorem. Okay, so real simple one here. I know this angle is 80, I know this one's 45, and I know together they add up to 125. Okay, so if I know this, all three of them have to add up to 180. If I subtract that 125, I find out that this missing angle right here has to be 55 degrees. And just to check, I add them together. 55 and 45 is 100, plus 80 is 180. Okay? And again, like we did before, we can take... hold on, my phone's going off and it'll be distracting. Sorry. Phone going off. I fixed that. Okay. So, we got these three different angles. And again, even though there's no measurements with any of these, we know they add up to 180. So I can just take... And watch how I do this. I've got 1x, I've got 3x, so that's 4, and then 2x, so I've got 6x. Then I got 11, plus 17 is 28, but then minus 10 is 18. Okay, so I got 6x plus 18, and again, I know those three angles have to add up to 180. So I subtract 18 from both sides. And I get that 6x is equal to 162. And when I divide, I find out that this is 27. So then I take that answer for x and I put it in this equation here. 27 plus 11 tells me this angle is 38 degrees. This one, if I did 2 times 27, that's 54. Minus 10 is 44. And then this one, 3 times 27 is 81. Plus 17 is 98. If I add these three numbers together, I would get exactly 180. Okay? Next, almost done. The exterior angle theorem. So the exterior angle theorem states that the measure of an exterior angle, okay, remember that's on the outside, is equal to the measurements added together. I didn't write that, but that would make sense. The measurements of the two interior adjacent angles. And here's all this means. I know it's a lot of words, but this is all this means. If I came over here and I drew a line right here, okay, whoops, there you go. If I drew a line right here, what you need to do, I just created another angle right here. This is an exterior angle. So let's say I knew this was 100 degrees, this angle right here. Well, there's a lot of different ways I can do this, but since this makes a straight line, I could figure out this one. But also, these two are the non-adjacent. Sorry, I said adjacent. One thing you need to fix right here, sorry. Non-adjacent, which means not next to. Non-adjacent, okay? That means not this angle, but these two. So this 100 in this case is what these two add up together. Well, that tells me this one has to be 70. Doesn't it? Yeah. 70 and 30 is 100. And again, the reason this works out is because if this is 100 and these two angles have to be 180, I know that's 80. And if I add those three together, I get 180. Okay? So let's do a few examples really quick, just see how easy this is. If I draw a line right there, and I tell you this angle is 105, well, I know that these two angles have to add up to 105. So I just do 105 minus 45 is 60. So I know this angle is 60. And I also know that this angle is then 75. All right. With this one, I got to do some substitution. But again, when I draw this line, I'm going to say that this is an angle of 134. Okay? Which I could figure this out really quick just by doing 180 minus 134. That's where I got the 46 right there. But I can't figure that out that easily by doing this. But I do know that this angle and this angle, when I add it together, is going to give me 134. So I take my similarity things. 3y and 2y is 5y. And I got 4 plus 5 is 9. And I know that has to be 134. So then I subtract 9 from both sides, which gives me 125. But I got to divide that by 5, which tells me y is now 25. So 3 times 25 is 75, plus 4 is 79. And 2 times 25 is 50, plus 5 is 55. Okay, and if I added these two together, I would get 134. Okay, last one, I want you to try this one right here. Notice that you got 3x and 2x, but first you got to draw a line here and use this angle measurement of 62. And just follow the same pattern I did to do that other one. Okay, the last thing we're going to do. Whew, arm's getting tired from holding this camera. Okay, here we go. The AA, which is angle, similarity postulates, states that if two triangles have two matching angle measurements, then they are similar because the third angles must also match. To find missing measurements of similar triangles, we use proportions. Okay? So if I look at this triangle, I got a little triangle here, 3, 4, 5. Okay, it's a right triangle. And I have to imagine this bigger triangle around it. So I have two triangles that are similar. And by knowing some of these things, I can figure out some of these missing measurements. So all we're going to do is one of them. So here's what I want you to do. I want you to draw this little triangle first. 3, 4, 5. And then draw the bigger one next to it. And I know that this long line is 12.5, but I don't know this one right here. Okay? So all I'm going to do to solve this is to write a proportion. 5 over 3. I'm using the matching side. So I did this line here and this side. The straight up line, okay? So over here I'm going to do the same thing. 12.5 over x. And all I need to do is just cross multiply. I get 5x equals 37.5. And then lastly, I divide 37.5 by 5. And I get 7.5, and now I know that this line right here is 7.5. Okay, so that's how that's going to work. All right, there's your notes. You got a lot of time to watch this, so maybe you split it up into a couple days, but hopefully you got some good information from this, and we'll do a lot of practice with this in class, and you should be very good at this, okay? All right, we'll see you later. Have a good day.